The students in a 2012 Leaving Certificate class decided to investigate their heights. They measured the height of each student in centimetres, and the results are as follows. So one student was 173 centimetres, another student was 167 centimetres, the next was 180 centimetres, and so on. Part 1. Construct a stem and leaf plot of the above data. So we're going to have a look at all the data values, and we're going to take the lowest height, the smallest height, which is 149. So we know that our stem needs to start at 14. And then we have a look for the tallest height, the biggest height, and that is 187. So our stem needs to go from 14 to 18. Next, we're going to draw an unordered stem and leaf. And in the next slide, we will have a look at the ordered stem and leaf. So it's very important that the stem and leaf plot is in order. But the easiest way to do that is to, first of all, even in a rough work page, draw out an unordered stem and leaf. So the first number is 173. So I'm going to write a 3 beside the 7 and tick off 173. It's very important that you tick off the numbers as you use them, because otherwise you might forget about one of them or use one of them twice. This is a very easy mistake to make. Okay, the next is 167, so I'm going to put a 7 after the 6 and tick off 167. Then 180, so I put a 0 after the 18, tick off 180. Then 168, so I put an 8 beside the 6, tick off 168. Then 180, tick off 180. 175, tick off 175. 171, tick off 171. 161, tick off 161. 164, tick off 164. 187, tick off 187. 176, tick off 176. 160, tick off 160. 170, tick off 171, tick it off 167, tick it off 178, tick it off 174, tick it off 149, tick it off 157, tick it off 161, tick it off 176, tick it off 166, tick it off 167, tick it off, and 172. So here we have our unordered stem leaf. Now we need to order it. So we don't have to do anything with the 9, which represents 149, or the 5, which represents 155. So for on the right hand side of 16, we go in order 0, 1, 1, 4, 6, 7, 7, 7, 8. So we're going to order from smallest to largest, and the smallest values are closest to the stem. Then for 17, we've got 0, 1, 1, 2, 3, 4, 5, 6, 6, 8. And then for 18, we have 0, 0, 7. So now we have an ordered stem and leaf. And we have a key at the bottom, which tells us that 14/9 is equal to 149 centimetres. If there's no key included, make sure to add in your own key. Part 2. Describe the distribution of the data by making one statement about each of the 3 characteristics indicated below. So the shape of the distribution. Well, if we have a look at our stem and leaf diagram, we see that most of the values are at the bottom of our stem and leaf. So we say it's left skewed. If most of the values were at the top, so in the 140s or the 150s, we would say it's right skewed. And if most of the values were in the very, very middle, and if we turned our head sideways to the right and we had a very symmetrical looking graph, we would say it is symmetrical. But because most of the values are at the bottom, we say it's left skewed. So next we want to talk about the location of data. So the central tendency or the average. So we want to find the median. So we have a look at how many data values we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So to find the median, we're going to divide 24 by 2, and half of 24 is 12. So since this is a whole number, and this is not the answer by the way, the median is not 12. Since this is a whole number, we take this value, the 12th, and the next one, the 13th. So we take the 12th and the 13th value, we add them together and we divide by 2. So the 12th value, so we're going to start at the start, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 170 is the 12th value, and 171 is the 13th value. So we take the 12th and the 13th value, we add them together and divide by 2. So 170 plus 171 divided by 2 is 170.5. So the median is 170.5. Now, when we had added up the amount of values, which happened to be 24, if when we divided by 2, if we'd gotten a decimal, we would have rounded up. So let's say this happened to be 12.5 or 12.75 or 12.25 or something like that. Whatever decimal we get, we would have rounded up. So we would have rounded up to the 13th value, and we would have just taken the 13th value as the median. So for example, it would have been 171. So when you're trying to find the median, you add up the amount of data values you have, you divide by 2 for the median. If you get a whole number as your answer, you take that value and the next one, add them together and divide by 2. Whereas if you ended up with a decimal here, you would always round up, no matter what it was, you would always round up and you would take that answer. So if, again, for example, you'd gotten, say, 12.25, you'd round that up to 13, and the 13th value, which is 171, would have been your median. The spread of the data, or the dispersion. So we're going to get the range here. So the largest value is 187, the smallest value is 149, and subtracting we get 38. So the range of data is 38. Part 3. State one additional piece of information that you would need in order to decide whether these students are unusually tall. So in order to figure out if the students in this particular group are unusually tall, we would need the average height of students of the same age group in their whole city or else in the whole country, and we would compare them. B. The students decide to look at the heights of the males and females in the class separately. The heights are given below. So here's all the heights for the males and here's all the heights for the females. So there's 12 males and 12 females. Part 1. Construct a back-to-back stem and leaf plot of the above data. So I'm going to start with the females. So I'm going to put the females on the right hand side. So again, I'm going to take the lowest value that I see, and it's 149. So, and the lowest value in the males, 149 is the lowest value altogether. So I start with 14 in my stem, and the highest value again is 187. So I need to go from 14 to 18 in my stem. Okay, so just like before, I'm going to start off by doing an unordered stem and leaf. So if you don't have space to do that in your exam paper, you can do it on extra paper. But make sure that your final answer is the ordered stem and leaf. But it is easier to start off with an unordered stem and leaf. So 167 is my first height. So I put a 7 beside the 6, tick it off. Then 161, so I put a 1 beside the 6, tick it off. 160, 157, making sure I'm ticking off each time. 164, 172, 168, 149, 161, 167, 167, 171. Now I'm going to do the same on the left hand side for the males. So we start with 173, so I put a 3 to the left of 17. 180 is next, so I put a 0 to the left of 18. 174, make sure you're ticking off as you use them. 175, 178, 176, 180, 171, 170, 187, 176, and 166. So here we have an unordered stem and leaf, back to back. Now we have to order it from smallest to largest. So on the right hand side, the smallest numbers will be on the left, and they get bigger as we move outwards. And on the left hand side, the smallest numbers will be on the right, and they get bigger as we move outwards. So you want the smaller numbers beside the stem, and they get bigger as we move outwards. So here we have our ordered stem and leaf. It's very important that we order our stem and leaf. So we didn't have to do anything with the 9 or the 7. So for the 160s, we have 0, 1, 1, 4, 7, 7, 7, 8. So notice the smaller numbers are beside the stem and we get bigger as we move outwards. For the 170s, we've just 1 and 2. And then on the left for the males, we have 6. Then for the 170s, we have 0. Then 1, 3, 4, 5, 6, 6, 8. So the smaller numbers are beside the stem and we get bigger as we move outwards. And then for 180s, we have 0, 7, 7. And then very important that we include a key. So 14/9 is equal to 149 centimeters. Now you can use any numbers that you want, but make sure you include a key. Part 2. State one difference and one similarity between the two distributions. So the males is on the left, the females is on the right. So some differences. Well, the female median is different. So we want to get the median of the females. So there's 12 females, and 12 divided by 2, so we half it for the median, gives us 6. And since 6 is a whole number, we get the 6th and 7th. And we add them together and divide by 2. So 6 and 7 is not the answer. It's the 6th and 7th data value. So 1, 2, 3, 4, 5, 6. So 164 is the 6th. And 7, so 167. So 164 plus 167, add together, divide by 2 is 165.5. So this is the female median. And we do the same for the males. So there's 12 data values on the left for the males. So again, 12 divided by 2 is 6. This is a whole number. So we take the 6th and 7th, add them together, divide by 2. So 1, 2, 3, 4, 5, 6. So 175 is the 6th value. And then 176 is the 7th value. So 175 plus 176, add them together, divide by 2 is 175.5. So the medians are clearly different. So just while we're talking about medians, if we had divided this by 2 and gotten a decimal here, so let's say we got 6.25, we would have rounded it up to the 7th value, and we would have got the 7th value, and that would have been the median. We would not have had to add together any two values and divide it by 2. So if you get a whole number, you take that value and the next one, add it together, divide by 2. Whereas if you get a decimal here, you round up to the next number. So let's say if this was 6.25, you'd round up to 7. And the 7th value, for example here, 167, that would have been your median. Okay, some similarities. The female range, well, the lowest value for the females is 149, and the highest value is 172. So 172, take away 149 is 23. So the range for the females is 23. For the males, the lowest value is 166. The highest value is 187. So 187 minus 166 is 21. So the range for the females is 23 centimeters, and the range in height for the males is 21 centimeters. So the ranges are quite similar. The medians are different.